Hello everyone. This question has been taken from Olympiad Pathfinder, multiple choice question number 24 and related to NLM, Newton's law of motion. The question is, near a station, a train is retarding at 2 meters per second square to stop. When its speed is 36 kilometers per hour, a passenger standing in the corridor of a bogie puts his suitcase on the floor. The floor was a little bit slippery, so the suitcase began to slide and finally stopped in the train after sliding 12 meters on the floor relative to the train. So according to this situation, which of the following statements are correct? 4 statements are given and we have to tell that which all options are correct. Number A is the train stopped before the suitcase stopped sliding. B is speed of the suitcase relative to the bogie decreases monotonically. C is the speed of the suitcase relative to the bogie first increases then decreases. D is coefficient of friction between the suitcase and the floor of the bogie is close to 0.3135. So let us try to analyze and solve this question. For the convenience, I have made the diagram. So this is your train. It was moving with 36 km per hour, that is with this, okay, in the x direction. We have taken x-axis in this direction and y vertically up. The train started retarding from this position when its velocity was 36 km per hour and the retardation magnitude was 2 meters per second square. Suitcase is kept here at the rear end of the bogie. Okay. Because of the retardation, the speed of the train will gradually slow down and finally it will come to a stop. So this is the stop position when the train stopped. Okay, so from here to here, the distance traversed by the train, we have taken it as capital X. But during this event, what is happening? Since suitcase was kept on the floor of the bogie and the train started retarding, means getting slower. So what will happen? Because earlier the suitcase was along with the train moving with the same velocity u in this direction, but now the train is getting slower. Suitcase being non-integral part of the body of the train, so it will start sliding because it will continue to move with the velocity u. Okay, moment it starts sliding, the friction force between the surface of the bogie and the suitcase will appear. Because of this friction force, a retardation will set up for the suitcase as well. So from the question it is given that suitcase once started moving relative to the surface of the bogie, it traversed a distance of 12 meters before coming to stop. So this is what we have shown with small x is equal to 12 meter. Okay, and here it is in stopped condition, so velocity of suitcase is 0 here. At this point, velocity of suitcase was u, the same velocity what was the train velocity, right? What was of the train. So in the question it is given a is equal to 2 meter per second square, which we have shown here, acting in the negative direction of x-axis. U is equal to 36 km per hour. After converting in meter per second, it is coming as 10 meter per second. Small x is equal to 12 meter. Now we are assigning capital M as the mass of the suitcase, coefficient of friction as small k, the distance by which the train travels just before coming to stop is x. So this distance which we have discussed already, and the suitcase traversed by x is equal to 12 meter. This also we have discussed relative to the train. Okay. So first we will write the equation of motion for the train to see how much distance the train has covered in stopping from this point to this point, that is x. So final velocity square, so this is the equation of motion, v square is equal to u square minus 2ax. U was the initial velocity, right? Negative sign has come because it is retardation, it is acting in the opposite direction of the velocity, right? V, finally the train has stopped, so V will be 0. So putting all this value 0, U as 10, A as 2, okay? So we will get x is equal to 25 meters. So this we got as 25 meter. So therefore the train, so therefore this suitcase traveled a distance of x plus x. X is the distance the suitcase has traveled relative to the train. So total distance for an observer standing on the ground will see that the suitcase has traveled a distance x plus small x. Okay, that is equal to 37 meter. Now see the concept behind it. When the train was moving with constant velocity, the suitcase together with it was having the same velocity as that of train. So that is equal to u. Once the train starts retarding, the suitcase being non-integral part of the train body will continue its motion in the corridor as per the Newton's first law. The friction force between the suitcase and the bogie surface will come into play moment it starts sliding relative to the surface of the bogie. So the motion of the suitcase will continue till it comes to a stop. So Vs is equal to 0, right? So let's say As be the retardation for the suitcase. Means As be the retarding acceleration for the suitcase. We will write the equation of motion for the suitcase now. Final velocity square is equal to initial velocity square minus 2 into As. Again, negative sign because of retardation into total distance cover is x plus s, capital X plus small x. Vs, the suitcase has come to a stop, so it has become 0. And u, we know that it was 10. So putting all the values, we got As is equal to 50 by 37 meter per second square. So it means this As was less than A. So retardation of suitcase relative to the ground was less than the retardation of the train. So therefore, the suitcase will take longer time to stop than the train. Hence, even when the train was stopped, suitcase will keep moving till its velocity becomes 0. So therefore option A is correct. Here the suitcase is experiencing only the friction force, which is throughout constant. There is no other force acting on the suitcase, only the friction force. And this force is throughout constant. Why? Because here there is no motion in the y direction. So normal reaction force is always equal to mg, and we know that the friction force is equal to k into normal reaction. So k is equal to mg. So therefore friction force is constant. So thus the speed of this suitcase will monotonically decrease because retardation is constant. Okay. So option B is correct. So if option B is correct, the option C will be incorrect. Now to get the coefficient of friction, we will make the free body diagram of the suitcase. So this is the free body diagram. So F is the friction force acting in this direction. AS is the retardation. N is the normal reaction force from the surface of the bogie. Mg is the weight of the suitcase. So from NLM, summation of Fy is equal to 0. Okay, no motion in y-axis. So therefore normal reaction is equal to mg. Similarly, summation of Fx means all the forces in the x direction is equal to mass of the suitcase into acceleration. So both acceleration and friction force acting in the same direction. So we have taken both as positive. So from here, if you put all this, the AS will be equal to F by M, and F, you know that K into M normal reaction, and normal reaction is mg. Okay. So finally you get K is equal to AS by G. Okay, AS we have obtained here 50 by 37, and G, you know that gravitational acceleration is 10. In the question it is given. To take it as 10, to cancel out, so this will be equal to 0.135. So option D is also correct. So overall in this question, option A, B and D is correct. So hopefully you understood the concept behind solving it. In case any doubt in understanding at any place, any point, please do write in the comment box. I will clarify your doubt. Thank you.